This is Unit 6, Day 3. Today we're going to be multiplying and dividing our rational fractions. So don't forget, yesterday we talked about what a single monomial was versus a marriage, binomials, trinomials, and how you can't just cancel. So these right here, A, B, and C, you're going to notice are monomials. So the easiest thing to do is just to multiply across. So 6 times 10 is 60. All over 8 times 3, which is 24, and then just put it in your calculator if you have to, and reduce those, or divide them both by 12, and you'll get 5/2. All right, B, again, multiply across. So you're going to get 80, and then you have a y to the 7th and x squared, and then multiply across the bottoms, and you're going to get 30x cubed, y cubed. Reduce those, and so you're going to get 8/3, and then 7 y's on top and 3 y's on the bottom would leave 4 y's on top, and then you have 2 x's on top and 3 on the bottom leaves 1 on the bottom. So there's my answer. Okay, again, part C, last one, monomials. They're single, 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 single. So just multiply across. You're going to get 60 over 36. And then, be careful here, okay, you got powers of 1 there. So remember, when you multiply and they have common bases, you add their exponents. So x squared times x to the first is x cubed. Y to the third times y squared would be y to the fifth. And then down here, again, power of 1 on x times x to the fifth would be x to the sixth. And then y to the seventh, y squared times y to the seventh, y to the ninth. Again, put it in your calculator. You could divide by 12 here too. 60 over 36 reduces to 5/3. 3x is on top, 6 on the bottom, leaves 3 on the bottom. And then there's 9 y's on the bottom, but 5 on top, so that leaves 4 on the bottom. Just going to center my 5. So there's my final answer. So if you notice, with the single monomials, just multiply across and then reduce. All right, looking at D, you can't just do that, okay? Because remember, these are marriages, so you have to factor. So I have a DPS over a trinomial times a GCF over a GCF. You have to be really, really good with knowing how to factor quickly with GCFs, DPS, and trinomials. All right, so the first one is a difference of a perfect square, and that's x plus 2, x minus 2. All over your trinomial, it's going to be x minus 4, x plus 3. Again, in your head, you're saying, oh, sorry, that is totally wrong. It's 3 and 2. I don't know what I'm doing there. Because negative 3 times positive 2 multiplies to negative 6, but negative 3 plus 2 adds to a negative 1. Okay, over here, GCF, I take out a 3x. I'm left with x plus 5. On the bottom, I take out a 6x. I'm left with x minus 2. So, now, you can cancel any top with any bottom. So, any numerator with any denominator that matches. You cannot go next to each other, numerator to numerator or denominator to denominator. It's got to be 1 on the top, 1 on the bottom. So, if you remember from yesterday, these are exact matches. They leave behind 1s. And then look, here's 1 on the top, 1 on the bottom, exact matches leave behind 1s. Okay? The last thing is these. To remember, singles can mingle. So x over x cancel, leaving behind 1s. And then 3 out of 6 reduces to a half. So up in my numerator, I'm left with 1 times 1 times 1 times 1 times x plus 5. It would be x plus 5. And then on the denominator, I have 1 times 1 times 2 times 1, which would be 2, times this x minus 3. So I'm just going to go 2 parentheses x minus 3. I do not recommend that you distribute down here on the bottom, unless you might have to. It's multiple choice, and then you could distribute that. Okay? All right, example E. So I have a GCF over a GCF, trinomial DPS. So if I factor out a 2x, I'm going to be left with x plus 6. On the bottom is a GCF. I'm going to factor out a 4. I'm left with x plus 2. That's going to be multiplied times a trinomial. So you're saying what multiplies to a negative 12 but adds to a negative 4. It's going to be x minus 6 and x plus 2. All over a difference of a perfect square of x plus 6 and x minus 6. Again, you can cancel any numerator with any denominator. Okay, so look, exact matches, leave behind ones, exact match, leave behind ones, exact match, leave behind ones. Okay, the last thing to reduce is the singles over here. 2 out of 4 is a half. Do not forget there's an x there though. Okay, so I have 1 times x times 1 times 1 times 1, which is going to be an x, all over 2 times 1 times 1 times 1, which is going to be 2. There's my answer. Okay, part F. Be careful with this DPS. You have to keep it in the order. It's 3 plus x times 3 minus x. If you wrote these reversed as x minus 3 and x plus 3, you're going to get that wrong. That is not the same thing. All right, the GCF on the bottom, take out a 2x squared. You're going to be left with x minus 3. Okay, GCF the numerator up here, take out a 4x, you're left with x minus 1. Okay, the bottom. You're going to say what multiplies to a negative 3 but adds to a 2? X plus 3, x minus 1. Okay, so cancel numerators and denominators. Be careful. These are exact matches, leave behind ones. Okay, believe it or not, when these are all positive, those are also a match because addition is commutative. So this is positive 3, that's positive 3. This is positive x, that's positive x. Those are a match. They leave behind ones. But yesterday we talked about opposites, the reversed. So you're going to leave 1 is a negative and 1 is a positive. The last thing to look at, the singles can mingle. So this 4 and this 2 reduce, leaving 1 and 2. But then the x and the x squared reduce, leaving a 1 up top but an x on the bottom. So my numerator is 1 times negative 1 times 2 times 1 times 1. So I get a negative 2. All over 1 times x times 1 times 1 times 1, which is x. Realize, guys, that's the same thing if you had 2 over negative x as well. Okay? All right. Next. Okay, so in middle school, they used to teach you guys keep, change, flip. Okay, you would keep the first fraction exactly the same. You would change the division sign to multiplication. And you would flip the last fraction. Okay? So at high school, we don't say keep, change, flip. We say multiply by the reciprocal. Okay, so you're going to multiply by the reciprocal. That's the high school terminology for it. Okay, so ready? You keep the first one exactly the same. And then it multiply by its reciprocal. So these two get flipped. Or keep it, change the sign, and flip it. So the denominator becomes the numerator, and the numerator becomes the denominator. Now, this becomes identical to what we just did in example 14. So for all the singles, the monomials, just multiply across. So I have 30x squared y to the 7th all over 30x to the 8th y to the 5th. Now just reduce, and you're going to end up with y squared up top over x to the 6th. Okay? Part B, they're all monomials again. So you're going to have 30y to the 6th all over 20x cubed times 8x, flip that last fraction, or that's the reciprocal, 24y squared. Multiply across 240, and then you're going to have x y to the 6th all over 480 x cubed y squared. Now look, 0 for 0 is gone, and 24 out of 48 is a half. So you're going to have a 2 on the bottom. You can put your imaginary 1 up there, but I think there's going to be something left up there to hold its place. So 1x on the top, 3 on the bottom, leaves an x squared in the denominator. And 6y's up top, but 2 on the bottom, is going to leave 4 up top. So my answer is y to the 4th all over 2x squared. Okay? All right, C. So I'm going to keep this, change it to multiplication, and then flip. Okay? So your 2x, just to show you the flip, you're going to have 2x plus 10 all over x squared minus 16 for that second fraction. Okay? But now I'm going to factor that as well at the same time. Let me move these over a little bit. So the first fraction, its numerator right here, is a trinomial. So you're saying what multiplies to a negative 8 but then adds to a positive 2? It's going to be x plus 4 times x minus 2. The denominator is the GCF. So divide out an 8, you're left with x minus 2. Change it to multiplication and then reciprocate. So you're going to GCF the 2x plus 10, that is now your new numerator. Take out a 2, you're left with x plus 5. And then your denominator is a DPS of x plus 4 and x minus 4. Okay? Now, this is just multiplication. Any numerator cancels with any denominator. Okay? If they're exact matches, they leave behind 1s. Okay? I don't think anything else. Now, the last thing is the singles can mingle. So divide those both by 2 and you get 4. So my numerator, I have 1 times 1 times 1 times x plus 5. Is x plus 5. And on the denominator, I have 4 times 1, which is 4. But then I also have an x minus 4. No need to distribute unless it's multiple choice. You'd have to look for 4x minus 16 down there. Okay? Part D. Okay, so I have a 9x squared minus 1, which is the difference of a perfect square. So I get 3x plus 1, 3x minus 1. You take the square roots of those. Okay? And then the denominator is a trinomial with a leading coefficient greater than 1. So I have 3x squared plus 7x plus 2. You could use AC method, slip and slide, or guess and check. Or if you're really good with the poly roots, you're going to get x plus 2 and 3x plus 1. Okay? Change it to multiplication, and those flip. So my new numerator is x squared minus 5x minus 14. My new denominator is 5 minus 15x. Okay? I am now going to factor those, though. So what multiplies to negative 14 but adds to negative 5? It's going to be x minus 7 and x plus 2. The denominator, GCF out of 5, you're left with 1 minus 3x. So now you can cancel any top with any bottom. So these are exact matches. They leave behind 1s. Here's 2s, x plus 2s. They leave behind 1s. But now, guys, don't forget, these are opposites. The orders are switched. When the orders are switched, leave 1 to be a negative 1 and 1 to be a positive 1. Doesn't matter if it's on the top or the bottom, just not both. Okay? So, now, my numerator, I have this negative 1 times 1 times 1 and this. So, I'm going to just put negative, put imaginary 1, and x minus 7 all over 1 times 1 times 5 times 1, which is 5. Okay? So, that is also the same as x minus 7 all over negative 5. So, either one is completely fine. Okay? Either one. Alright, last example here. Example 16. So, the first fraction is a DPS. So, right here, it's going to be x plus 5, x minus 5, all over 3x. I'm going to change it to multiplication. This fraction gets flipped. So, don't forget to flip that. So my new numerator is 9x, and then it's over x plus 5. Okay? Matching x plus 5s get reduced to 1s. And now look, guys, 3x into 9x is just going to leave a 3. Or think of it as divide them both by 3. You're left with a 1 and a 3, and then the x's are gone. Okay? So I have 3 times 1 times 1 times x minus 5. So that is going to be 3 times x minus 5 all over a big 1. Now, if you look at your choices, those aren't a choice. So you actually have to distribute that, and you're going to get your 3x minus 15, which is choice 2.